All right, folks. In the last one, we talked about complex conjugates. We talked about graphing complex numbers and lots of other really fun math things. So in today's video, we are going to talk about, well, guess what? The absolute value of a complex number. It's really not too tricky, and I'll kind of explain it. It's pretty well explained, I think, already, kind of on the slide. If you just kind of, open your eyes and read a little. I'm just kidding. But absolute value. So remember absolute value, just in case you forget what absolute value is. When you're talking about the absolute value of a number, you're really asking, how far away is that number from 0? So when I ask, what's the absolute value of -4, you say +4, because -4 is, count it, 1, 2, 3, 4 units away from 0, right? We count distance as a positive number every single time. We don't count distance as a negative number. We don't say, I've got to drive -5 miles to Walmart. No, you would just say, I'm driving 5 miles to Walmart, okay? I don't know why. I always use Walmart because it's a nice little place sometimes. Anyway, so absolute value is a distance from 0. So as we looked last time with our graphing complex numbers, let's say you can see here, graphed is 3 plus 4i. Notice where it is. It's not at 0. It's some distance away from 0. So our goal is to find out just how far away is that point from 0. What is the distance of squiggly, okay? What is the distance of that line, okay? Lots of arrows to emphasize I'm talking about this line right here, this red one, okay? That's what we're trying to find out. And now to do that, it's pretty simple. If you guys ever talked about or used a Pythagorean theorem before, it's basically based off of that. If you know the distance of this, is it called a leg? I don't know what it's called. Okay, if you find the distance of this and then the distance of this, right? The Pythagorean theorem tells us a squared plus b squared equals c squared. So this would be a, this would be b, this would be c. So if you square this, you square this, you square that, then this equation is true for right triangles anyway. So we're essentially doing that because, why did I erase it? I still kind of needed that. If you square root to get c by itself, you square root that side as well. So c is equal to the square root of a squared plus b squared, which is the formula that we're going to be using. Okay, you can just be quiet. All right, so that's why it's a pretty basic formula, and that's where it stems from. But to find the absolute value of a complex number, we're going to use that Pythagorean theorem to help us out. Now notice that even though the complex number has an I in it, we don't actually use the I when we're plugging it in. All we're plugging in is the A and the B part, because those are just essentially the distances of the legs, right? If the real number is 3, then you're going 3 places over. And if the imaginary part is 4i, then you're just going 4 places up. And we don't really need the I part. We just need the distance themselves, which is 3 and 4. And you can see that's what they use in the formula for A and B. And they solve it, and you get a number and an answer. And it's all very wonderful stuff. And there's flowers and rainbows, and we're all celebrating. It's very happy times. All right, let's try it out. So find the absolute value of each of these. So I read that wrong. I wronged that read, but I did the best I could. Okay. Now, so for this one, notice the A is 3 and the B is 5. Now, why did I do that? Okay. Not really concerned with the I. Okay, we're just going to say, hey, if I want to find the distance from 0, I'm going to use my formula, a squared plus b squared, right? A is 3, so I want to square root of 3 squared. What's going on? What? 3 squared plus b squared, which is 5 squared, right? So a is 3, b is 5. I plug them in. This is going to be 9 plus 25. Don't forget the square root still. And 9 plus 25 is 34. So we have the square root of 34. Ta-da is the answer for A. I'm hoping that shows up. There we go. So it's pretty simple overall. Just remember the Pythagorean theorem, remember the formula, you're all set. So here A is 1, B is -2. It doesn't really matter if it's negative or positive, because when you square it, it's going to become positive anyway. So just be mindful of that. If you're clever, you don't really have to use a negative. If you do use a negative, you have to remember to use it in parentheses. If you're using a calculator. So square root of a squared, which is 1. So 1 squared. I'm going to put that in parentheses just for fun. Plus b squared. I just spit a little. B is negative 2, so you have negative 2 squared. So use a calculator and type that in if you want to, or 1 squared is 1, negative 2 squared is 4. So we have the square root of 1 plus 4, which is square root of 5. If you don't believe me, why did you just do that? That made no sense, man. All right. Spoiler alert, the next answer is 7. I wonder how that happened. So A in this case is 0. B is negative 7. Okay, so when you're using the formula, you would have 0 squared plus negative 7 squared. And this would be the same thing as 0 plus 49. 0 plus 49 is 49, and the square root of 49 is 7. Now, you can use that whole formula, but if you just think about it, I'm going to put that on a graph. If you just graph the point negative 7i, right, 0 real parts are not going left or right on the real axis, just going down 7 on the imaginary axis. It's right here, right? That's the point negative 7i. And because it's a direct root to 0, it's an easy 7 units away from 0. So you can think about it graphically too. That's somewhat helpful. All right, but if you don't believe me, just let me hit my button on my pen a few times, and now you know. Okay, now you know. And then the middle part, what was that? The square root of 5. Yep, see, I was right. I don't know why I did in the wrong order, but it's fine. Adding and subtracting and multiplying. Use the calculator. We will use the calculator, but we're also going to do it by hand. But I will show you how to do it on the... Well, can I? I don't know if I can. You might have to just come to class for the calculator part, because I don't have the graphing calculator on this thing, my tablet. But if I ever get it, then you'll know, because you'll see it in the video. Anyway, adding and subtracting complex numbers. This is pretty straightforward because it just follows a simple rule, adding and subtracting. This goes the same for pretty much everything, okay? Adding and subtracting, all you're doing is circling. All you're doing is combining like terms, okay? I'm wasting enough of your time. Combining like terms, it's really all that's going on. So I know there's parentheses. Don't get too carried away with the parentheses. I know sometimes we see parentheses like distribute, but notice what's in the middle here. Plus sign, a minus sign, a minus sign. Do what those signs say. Add them. So 6 plus 1 is, wait for it, leave you in suspense a little bit, wait for it, 7. Okay. And then you have the imaginary parts. You have negative, let's use a different color here because it's gonna look real fancy. All right, negative 4i plus 3i. So negative 4 plus 3 is what? Negative 1. So we have negative I. So 7 minus I. That is the answer. So you're just combining the real parts, combining the imaginary parts, just like combining any kind of like terms, and that's it. So number 13. All right, let's just, let's trigger you guys a little bit. The real part is 3 and 5. Now notice we're subtracting. So keep that in mind. It's 3 minus 5. 3 minus 5 is, wait for it, negative 2. Now, I'm going to use red this time. The imaginary part, negative 2i minus negative 4i. Let me write that down in case you didn't hear me correctly. Negative 2i minus negative 4i. Okay, so the minus sign is this. The negative is that. Notice it's double negative. Double negative turns into a positive, if you want to think of it. So negative 2 plus 4, which is a positive 2. So we get plus 2i. Jeez, man. Plus 2i there. So our answer is negative 2 plus 2i. There you go. Remember, these are not, you cannot combine these. Don't say it's 0 or 4i or what. Don't do something silly. Remember, real part, imaginary part, don't go together. This is a complex number. This is one number. Okay, leave it like that. All right, it should always be in the form a plus bi. Some real part, some imaginary part, unless one of those is 0, then you wouldn't have to worry about it. But yeah, make sure you write both pieces. So our number 14, make this even better, okay? Green. Real part, 3 minus 1. 3 minus 1 is 2. This is groundbreaking stuff. Negative 4i minus negative 4i. Ooh, what just happened? I had negative 4i minus negative 4i. So again, it's a double negative thing going on here. Negative 4 plus 4, if you want to think of that, because the double negative turns into plus, is just 0i. So plus 0i. So the answer really just 2, because 0i is 0, so the answer is 2. Multiplying. Pay attention, okay? Pay attention. And maybe a little bit of money. I do a lot of work for you. I just said do. Anyway, multiply complex numbers. I'm watching the football game right now. Oh, they're gonna take a knee and they're gonna win. All right, they're good for them. Multiplying complex numbers. So it's the same thing as any kind of multiplying. Now notice they look similar to the last problems, but there is no plus sign or minus sign between them, right? There's just no space between them, which means you're multiplying. So pay attention to the difference between this and this and that. They look, okay, that's a hot mess. Let's just erase that. They look similar, right? They got 2 complex numbers in parentheses, but the difference, these have plus and minus signs between them. These do not. So pay attention. Plus minus means add or subtract. No plus minus means multiply. So distributing, remember the FOIL thing? Okay, neither do I, but we're using it again. 3 times 4. 3 times 4 is 12. 3 times 6i. 3 times 6 is 18i. Negative 5i times 4. Negative 5 times 4 is negative 20, so negative 20i. And negative 5i times 6i. So negative 5 times 6 is negative 30. Now be careful, because I and I make I squared. So a lot of people forget about this I squared. They write just I there most of the time. So remember, when you have an I term times another I term, you don't only multiply the numbers, but the I times an I combine to make an I squared. So remember that. Very important stuff. So there's also another very important step here that we need to remember. Notice first we have like terms. So 18i minus 20i, that's pretty easy. That combines into what's 18 minus 20? Negative 2, so negative 2i, right? Right? And you might think, oh, well, hey, you know what? We're done. No more like terms. And you would be wrong, because there's something else we have to do here, something we didn't have to do with quadratics, but something we need to remember here. And I talked about this several videos ago. Remember, we talked about I squared. Do you remember what number I squared is? Because we talked about it. I'll give you a second to go back. I'm not going to write the answer. I'm just going to sit here. I'm going to wait for you to click on another video and then find out what I squared is, and you report back to me. And once you report back to me, I will finish the problem. So I'll wait. Don't worry. I'll wait. No rush. Did you pause the video yet? Did you go back and find out what I squared equals? Did you remember what I squared equals? Did you write it down in your notes? Did you do something? I'm waiting. All right, I don't believe you. I don't think you went back. But anyway, it's negative 1. I squared is equal to negative 1. So when I have I squared here, which that's a terrible looking I squared. I squared. I have I squared. That means I really have negative 1. That's a really ugly arrow, but that is negative 1. So what this really is, why do you do that, man? What this really is, 12 minus 2i minus 30 times I squared, but I squared is really negative 1. So it's negative 30 times negative 1. Now, if you can remember to do that, it's pretty simple because all that's going to happen when you multiply a number by a negative 1 is it's going to change its sign. So really it's, 12 is 2i plus 30. Okay? And now you have another set of like terms. You didn't just have these I terms here. You've got these constants. 12 plus 30 is 42. So when you combine those like terms together, you have 42, and then you can have your minus 2i. So this is your real final answer. So it's a very important step, and it's so important that I'm going to use red, and I'm going to circle it a bunch, but I squared is negative 1. Please remember that when you have I squared equal negative 1, that you plug it in and solve the problem. Okay. Oh, whoa, hold on, there's more math to be done there. Let's go back. Erase that. Let's try number 16. 3 times 5 is 15. 3 times negative 2i is 3 times negative 2 is negative 6, so negative 6i. 4i times 5. Don't be rude, okay? It's not nice to call people names. 4i is the term I'm talking about, okay? I'm not talking about something else, okay? 4i times 5. 4 times 5 is 20, so we have 20i. And then 4i times negative 2i. 4 times negative 2 is negative 8. But remember, I times an I makes an I squared, okay? And burns the world down. So 2 things I'm going to do here at the same time. I'm going to combine these terms. Negative 6 plus 20. So that's going to become, what's negative 6? Oh, did I say times? Negative 6 plus 20, I don't know what I said, is 14. So it's going to be 14i. And I'm also going to go ahead and convert this. This is negative 1. So this right here, that's negative 8 times a negative 1. Because it's negative 8i squared, it's negative 8 times negative 1, which is a positive 8. So I'm going to write plus 8. And then I'm going to combine the 15 with my plus 8, which makes 23. So I have the answer 23 plus 14i is my final answer. One more, number 17. All right. Number 17, 1 times 2 is 2. 1 times I is 1i. I'm just going to go ahead and write that. Negative 4i times 2 is negative 8i. And negative 4i times I is negative 4i squared. So hopefully you followed me on that. Remember that I squared is negative 1. And let's combine these as well. So this will become 2. What's 1 minus 8 is what? Negative 7. So negative 7i. And remember, so negative 4, this is what I have over here. Negative 4 times negative 1 is going to become a positive 4. So this will become plus 4. So 2 plus 4 will be 6. So my final answer will be 6 minus 7i. Because 2 and 4 combined to make 6, and the minus 7i I would just bring down. But I wrote it off to the right-hand side because I didn't write on the nice wood floor here. Okay? If I wrote on the nice wood floor, I'd probably get in trouble. Okay, I kind of did a little bit, but it's our secret. Okay. All right, I'm going to end the video here because dividing complex numbers is a whole other beast. It's going to take, 10 minutes of its own time. So I'm going to save that one for later. But I will say, when you're dividing complex numbers, we're not really going to divide at all. Dividing is kind of a joke. We're going to be doing the same thing I just did, multiplying complex numbers. So you know what we did with the I squared? Well, we're going to do more of that in this problem as well. But you'll see that in the next video. Good luck. Bye.